Go.
Hello everyone. In this video, we're going to be solving an AP Physics C problem. In this question, Johnny is on the edge of a cliff holding multiple balls within his hand. The height at which Johnny is located can be represented by h. Johnny then throws the balls at a velocity of g of x. G of x can be represented by the frequency of the ball's throws and the wavelengths between each one divided by 30. Remember, what does wavelength times frequency equal? Ignoring air resistance and friction, at what length would the ball roll if Jimmy threw it from a height of 40 meters and throws the ball every 4 seconds? And at what value of t would he throw 5 balls at a distance of 100 meters? This would be the problem that would represent how we could solve this. We're trying to solve for the speed of light. Cookie, you could take it from here.
Okay, guys, so the formula we're going to be using for this problem is to find, so we're going to be trying to find the speed of light, right? And to find that, we're going to have to isolate C through this process of dividing. So we know that he threw it from a height of 40 meters. So we know that V0 t plus 1/2 a t squared is equal to the height, which is 40 meters. And since these two equations are related due to the speed of light being in every single part of the natural world, we can set these equal to each other. So 40 is equal to this. And we want to isolate C. So all we're going to do is divide 40 by the integral from a to b of f of x, which is our original function, g of x in this case, dx, which means respect to x, times omega as x approaches 7 of the second derivative of the sum of the difference in the distance. So the distance, as you can see, is f of x sub n minus f of x sub n minus 1. So what this basically means is at a certain time, the distance between the two balls, or each ball, since we're throwing multiple balls, there will be two balls, and that's the distance between each of them. So then we're doing as x approaches infinity on the bottom interval of the sum, and then the n approaches infinity on the top interval of the sum, and then this is multiplied by the obvious, everyone should know this, it's in every formula, cosine log of cosine log of cosine log of cosine, it keeps going forever and ever. And I forgot to mention that x approaches log cosine of n of root sine omega. So now that we divide, C is equal to 40. Let's say that all of this is equal to smiley face. This is just some variable we're going to use. So this is going to be 40 divided by smiley face. But Solost, I feel like we're missing something here. There's something that makes this problem unsolvable. Would you go over that with us?
In this equation currently, there are some limitations, but before we reach those limitations, we should still attempt to try to solve the equation. There's also a way where we could simplify and make this less complex. For example, this 4xn and all the way to the cosine, it could be simplified to 3 omega to the power of 4. This gets rid of a lot of the problems we see over in this entire complex equation. We can also simplify f of x to equal g of x, since that is what we're trying to solve for. So now the function becomes more clear as we're almost at the point at which we can find how many meters Jimmy or Johnny can throw 5 balls. Cookie, now that we have simplified this equation, will you be able to continue this and take us to the end?
Okay, so now we know that 40 is divided by the integral from a to b of g of x, since we proved that f of x is equal to g of x. And then we know that this entire thing is just multiplied by the second derivative of Since it's a derivative of a sum, we can cancel out the sum because we know that this will be a constant. So it's just 3 omega 4. And so it's the second derivative of 3 omega 4 with respect to x. Since omega, we know that omega is equal to the equation of a parabola. We can do impartial differentiation to find this out. So by using impartial differentiation, we're going to have to do 3 omega 4 with respect to t dy over dt to be exact. And the y in this case is g of x. So I'll just put that here. So now we know that the second derivative of this, that goes away because that's just a constant. This is times 1. So now we get 40 over the integral from a to b of g of x. And c is equal to that. And so we know that this is 40 divided by, so we know that g of x is 100 to the power of 5 because it's 100 balls and we're throwing it 5 times. And this will give us 299,792,458 meters per second, guys. Do not forget your units. And so, can you fact check that is actually the speed of light?
Well, we also need to multiply this by the derivative of omega as x approaches 7 and as h approaches an unknown number. However, since h approaches an unknown number, this problem can actually not be defined. So, in the end, Jimmy throws an undefined amount of balls. So, and that notation would be U and F.
Yeah.
And that's how you solve how many balls Jimmy can throw at
So,
100
guys, this
meters.
would be an AP Physics C FRQ number 2. We already posted FRQ 1 on our channel, so please look for that. This is definitely going to appear in the AP Physics C exam. And yeah, make sure to expect a problem just like this.
Yes.
Okay, guys. Well, thank you guys for watching. Goodbye.